Okay, so this is continuing 2.5. This is really the video that I'm going to start talking about proofs, what they look like, kind of how you think through it. For proofs, really, the best way to teach you is just to walk you through how your brain should think. Okay, some of the stuff is not just going to jump out and obviously be something simple. Okay, you're going to actually have to think, okay, how do I know this statement is true? So you're going to have to think back to those properties and think back to those definitions and those postulates. What knowledge do you have? What factual knowledge do you have that lets me say these statements are true? Okay, so first, one of your definitions is, what is a proof? Well, a proof is just a convincing argument that uses deductive reasoning. Okay, deductive reasoning is just facts, things that we know are true. How can we use those to say what we want to say? Okay, all the proofs that you are going to be doing are in the form of a two-column proof. Okay, so a two-column proof is exactly what it says. It's two columns. On one side it lists the statements, and on the other side is the justification or the reasons. So what that looks like, I'm going to add it right here. You have statements on one side. It usually looks like a T-chart. Statements on one side, reasons on the other. Majority of the time, all your statements are going to be filled in. You have to find the reasons. Okay, so we are going to move into example 1. The first one's kind of easy, just to kind of get you through what it looks like and then what you have to do to follow through. Alrighty, so example 1. This is how a proof usually is going to look. You are going to have a given statement, so that's what you start with. The further we get into geometry, the more likely you're going to have a diagram with your proof. So this just lets you know what you're starting with. And then you also have a proof. So you start with this, and you need to reason your way to figure out how you can say that your final conclusion is that x equals 4. Okay? Now, for right now, statements are going to be given to you. So they list each statement for how you can get 5x plus 1 equals 21 to your conclusion of x equals 4. We have to fill in the reasons. Okay, now the first reason is going to be given. Okay, think about this. We're trying to figure out, whenever we do a proof, how in the world we got to step 1. Well, we can say that 5x plus 1 equals 21 because, hello, they gave us 5x plus 1 equals 21. So, I'm going to let you in on a little secret right now. The first step is always going to be given, okay? As long as this first statement right here matches your given statement right here, your first step is always given, okay? So now, we need to move into reason number 2. Now, whenever you get to reason number 2, let me erase that. You need to figure out how you got from statement 1 to statement 2. Okay, so what in the world did we have to do to get from 1 to 2? Well, if you notice, this 1 disappeared and 21 went down to 20. So, notice, algebraically, we subtracted 1 from both sides. So, how do we know we are able to subtract 1 from both sides? Well, go back to the properties I gave you in the last video. Subtraction property of equality, okay? You subtracted 1 from both sides. That is, by definition, the subtraction property. Okay, so now reason 3, we need to figure out how step 2 got to step 3. Okay, well notice 5 was here, now it's not. So we divided both sides by 5. So going back to our knowledge, how do we know that we can divide both sides by 5? Well, in a property you just refreshed yourself on, You probably don't even think of it as a property. But anyway, we divided both sides by 5, and that is the division property of equality. Okay? So then that would be the end of the statement. You are done. Okay? So let's look at example 2. It's a lot more in depth than example 1 was, but this is realistically more likely how you're going to see proofs. Okay? So let's work through this. You have your statements, you have your pictures. So you're given that angle 1 is equal to, or the measure of angle 1 is equal to the measure of angle 3. So angle 1 is here, angle 3 is here. Well, yes, they're equal because we have our little red tick marks. But anyway, so we're trying to prove that the measure of A, B, C, I have messed up somewhere. If you will, just hold on a second. Okay, I have found the error in my ways. This should be AEC. Oops, sorry, my iPad just fell. AEC. Okay, let me fix this. I'll be right back. Okay, I fixed it. We're good to go. Okay, so now, reason number 1. We need to figure out our reason number 1, which tells us how in the world we got the measure of angle 1 is equal to the measure of angle 3. Well, remember what I just said. Your first reason is always given because, dun, 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 your first statement is always going to match given. So, statement 1, given. We're good. So now, statement 2. The measure of angle 2 equals the measure of angle 2. What? That seems dumb, doesn't it? Like, why do we have to tell ourselves that the measure of angle 2 equals the measure of angle 2? Well, let me tell you. If you refer to this later on, so notice how right here the measure of angle 2 gets involved. Before we can use something, we have to mention it. So here, let me try to change colors, and I can explain this more if you're struggling in class. So here we talk about the measure of angle 1 and the measure of angle 3, okay? Voila. So before we can talk about this measure of angle 2, we have to bring it up, which is exactly what they did. Now, right now, they're giving you the statements, so you don't have to think that far in ahead. You just have to say, well, how in the world did I get 1 to 2? And in this case, you really just need to know what property tells me that the measure of angle 2 is equal to the measure of angle 2. Well, remember what I said about looking in the mirror? You see you, that's your reflection. So this is the reflexive property of equality. Okay, so then we move to statement 3. So how in the world can we say that statement 3 is a thing? So what do we notice happens? Well, if you notice right here, we are adding the measure of angle 2 to both of those. So what allows us to add the same number to both sides of the equal sign? Well, I'm glad you asked. That would be the addition property of equality. Okay, so now move to statement 4. So where in the world did this statement 4 stuff come from? So we have the measure of angle 1 plus the measure of angle 2 equals AEC. So AEC, well, that's kind of obvious that 1 and 2 make up that angle. Okay, and then we have the measure of angle 3 plus the measure of angle 2 equals DEB, which is this angle right here. So we need to figure out what in the world this means. Okay, so what in the world allows us to say this? That 1 and 2 gives you AEC, and that 3 and 2 gives you DEB. Okay, notice we're talking about little angle plus little angle that gives you a whole big angle. Think back to our good old postulates. Okay, we know that 2 smaller angles can give you that larger angle by using the angle addition postulate. Okay, so we know that 1 and 2 gives you AEC because little plus little equals big. Same thing for 3 and 2 gives you DEB. Okay, so now we need to move from 4 to 5. So how in the world can we go from 4, saying all that angle addition stuff, to saying AEC is equal to DEB? Well, does anybody know? I'll tell you. Okay, all we did was switch what they were equal to. Now, how in the world can we do that? Well, if you notice up here, hold up, let me get a highlighter. We said that angle 1 is equal to angle 3. So if we know these two blue boxes are equal, then we can still add the measure of angle 2 to both of those, and it's not going to change because 1 and 3 are actually the same measurement. So then we can say that AEC and DEB are the same because all we did was just substitute. Okay? So I know this was a long video, and it's going to take a lot to do proofs. It's one of those things that you are just going to have to practice over and over and over. If you know your postulates, it helps greatly. If you know your definitions, it helps greatly. Now, if you know these, what did you learn? If you know these properties, that's also going to help. Okay? So just be prepared in class to work hard with the proofs. Okay? It's just practice. Okay? So that's all I have for you. Adios.